We're on. Why, hello. Welcome to the Marine Science Program Live Lab Days. I'm Dr. Elizabeth Lacey, Dr. Z. It's been our third attempt to try and get out here and do some SAV with Dr. Z, but the weather has not cooperated, and it continues to not cooperate now. So much that you can see that our boat captain is actually off island right now because we could not get a firm anchorage in the wind. So we're doing a little modification here, and Susan Allen is behind the camera, so thanks for coming out to help with that. We're going to start kind of in the back area of Barrel Island, show you some of the freshwater or the brackish areas of the marsh. You can see there's lots of birds, lots of salt marsh plants, and leading into the submerged aquatic vegetation, which is what I do for a living. But I also teach marine botany here at Stockton, and so we kind of created this series to bring our world into your home, given that we can't all get out on the water as much as we'd like. So for marine science students to anyone interested in marine science, hopefully you've been enjoying the series. Next week will be our last one, which is on Tuesday at 2 o'clock, and it'll be Ask a Marine Scientist. So we'll have a panel of 3 of our faculty members, some that you've already seen this week, and you can ask all sorts of questions then as well. But feel free to chime in now if you have questions, as we're gonna kind of walk around the marsh first. And then rather than getting in the water just because it is full choppy out there, there's actually a lot of really fun stuff to find within the rack line, so the seagrass line that is along the shore, which is probably what you're really familiar with when you walk on the beach. So here though, we're standing in a salt pan. So within a marsh environment, there's certain areas where the plants aren't growing and the salt content is really, really high. And so only those plants that are really well adapted to this salty environment are going to thrive here. And so we have some examples here growing along the edge. So the salicornia, so it's called pickleweed. You can eat this in certain locations where we know that there hasn't been influence from roads. And so it grows really lush and full throughout the season. If you've ever driven past a marsh and you've seen it look like there's something bright red and orange, some of those gorgeous colors you may have seen, you have this pickleweed to counter for that. We also have some taller vegetation, so when you're looking out over a marsh, if you see that there's a change in the plant height, it can be one and two things, and they actually are the opposite. Sometimes you get really tall reeds next to the water, or in this case, some of our bushy plants here, some would be groundsel bush or marsh elder, grow on the higher parts of the elevation. They can't handle the salt quite as well, and so they want to kind of retreat away from it. And then most of the other area here you see is full of the grasses that you would see on a lot of the marsh. So whether that is cord grass, you see some of the taller stands of things like Phragmites are the really tall, or big cord grass is another one. You have salt marsh hay, so all sorts of examples that maybe if you've been driving around any place in New Jersey with the shoreline, you might have seen some of these salt marshes. We've got a little pond here as well. So within the pond, we've got examples of both seagrass and seaweed, which we're going to look at more in depth out at the coast, and so, or at the beach there. And so you've got different examples of the seaweed, as well as, if you kind of peel back the surface, some of the grasses. And so it just goes to show you that there's a bit of an ecosystem everywhere on the marsh interacting in different ways. So some of these ponds do support fish, if they're at all tidally influenced or have that connection. You'll see a lot of birds like to hang out here. If you're a birder, you already know that information. But it's that base of the food web. So the algae and the seagrass, both types of plants, are the food, the nursery that feeds into all the different trophic levels that you see on the marsh. So we've got lots of birds already hanging out here, so we know we're in a good spot for them.
Courtney says hi, and folk across the street says no sunscreen needed today.
No sun, yeah, it's a bit windy today for sure. So we're headed now up over the marsh surface. So you can see this opens up into Beach Haven, is kind of out here in front of us. The white caps definitely tell you it's a windy day out there, and so it's an interesting dynamic because we've got the wind coming from one direction, but the tides are giving us a different direction, which makes it a bit challenging. Hence the reason Liz is out on the boat and making sure that she doesn't float away while we're trying to do things on shore. So she dropped us off on the marsh, and now we're going to head on to the beach. So already you can see that there's some couple different things when you're at the beach. So some of it can be the seagrasses, some can be seaweed, and then you also have the marsh vegetation itself. So if you see things that look like straw or hay, that's coming from the marsh rather than coming from a submerged aquatic vegetation kind of plant. So this bay right here, this is Barrel Island, and it's part of one of my long-term monitoring stations. It's really important that we protect the seagrasses and we understand the health of the seagrasses within the bay. And we only get that information if we track it over time, because it's that food source. As I said, it's a nursery habitat, those little baby fish. If you like scallops, they're settling on the blades of seagrass. If you like to protect the shoreline, right? If you have a beach home and you want your home to still be there, seagrasses help hold the soil in. They work in concert with our salt marshes. So it's a really important, economically, finance-wise, to the dollars and cents that are the value within seagrasses really can't be compared. And it's really a treasure of Barnegat Bay that I don't know that many people understand, because they get confused about the difference of seaweed versus seagrass. So I'm going to next show you kind of some of the differences with things that were actually already washed up here. So there was no planting of material. When we decided we'd have to do this from the beach rather than in the water, you never know what you're going to find. And I feel like there's a veritable treasure on this little cove here. So we're going to walk over to the rack line. So looking in the rack line, you can see that this is mainly seagrass. So all of these blades were once affixed below the surface of the water. So like the grass on your lawn, we're looking at the same thing, but now in this case it's a terrestrial grass, which it wasn't original. So this one's a bit greener, means it didn't really dry out. This will all die, and it's important that we keep this kind of material on the beach because it gets folded into the soil, the sand, and that's an important nutrient for worms, for birds. You'll see birds coming along and picking within the seagrass, and so it's important that we don't necessarily scrape this all off the beaches, which I know is hard, because when you go to the beach, you want to lay on the nice sand. And so kind of a happy medium is that you can fold it into the soil, the sand, so that it still is there for the ecosystem and community, but you don't lose the economic value of having a really pretty beach. And so this is a blade of seagrass, and so you can somewhat see the veins, because just like the grass in your lawn, it has ways to transport nutrients up and down the leaves, and the root here is completely sheared off. So we should be able to find, there'll be many other examples, and I'll show you the root there. So seagrass, it's narrow blades. This is an example of eelgrass. There are other examples that look a little bit different. Some have short stubby blades. So in Florida, where I've done some monitoring work, the blades look a little different, but this is the one in New Jersey you're going to see most frequently. So it's got, you know, that root system that I'll find. So this one's a little bit more intact. See the little brown bit and little root hairs. And there's even a bigger root that goes through there. And I saw some seeds, so hopefully we'll find some more seeds as we go. But the idea is that, you know, this roots into the soil underneath the water, and then it grows up in the water column. And just like the grass on your lawn, it's going to need some nutrients down at the soil, and then it's going to need some sunlight for the blades to photosynthesize, to produce the food so that it can keep growing tall and provide all the habitat for the fish, the scallops, the flounder, the blue crabs, you name it, whatever you like to eat. You have seagrasses to thank for it in some way, shape, or form. And so that's the identity of what a seagrass would be. This is different than a seaweed. So then we're going to head over this way a little bit. So still within this rack line, a lot of this you can dig through and you might see more and more of it. But we've got examples of different types of seaweed. So this is just what's naturally washing up. This one is called sea lettuce. So it's really, really thin. You can completely see my fingers through that sea, and it tears easily. So just like a tissue paper almost. And we're looking at, you know, it's a very thin surface rather than having, so if we look at, here's our seagrass again, another example. This one here's that little root. So if we've got that seagrass blade, commonalities, right? They're both green. They have the same pigment to photosynthesize. They both need light, but the nutrients for seagrass, they're only coming in from the root, whereas this whole thing is all gathering nutrients. So it's all the source of energy for this plant, which is why we get really big blooms of macroalgae or seaweed, is because they're not restricted. They don't need just that one space. They got their whole body to take it up. So that's one example, and this one's, you know, pretty easy to determine, okay, is that seagrass or is it seaweed? This one's pretty easy. As we get into some of the branching macroalgae, seaweed, so this is another example of seaweed. And so this one is called hookweed. Hookweed is called that way, so if you were to kind of pile this onto the ground, it's kind of hard to see with all the other grass here. But if you were to put this on the ground, each one of these little branchlets kind of forms a little natural hook when you lay it down. And then each one of these little end pieces has hooks to it as well. So still not too similar. You know, now we've got kind of a brown coloration, which is what some of the decaying, the dying seagrass blades look like. But as that's tumbling on the beach, you might think, oh, seagrass, seaweed. So this, once again, nutrients are being taken up by the entire body, the whole thing, and it has no true root. Like where would, if we're looking at the root of seagrass, it's much easier to say. So like, okay, here's the bottom, here's the top. But this whole thing is bottom and top taking up nutrients. Then we have other examples. So there's some harder to see out of the water. So this one is a bit red in coloration, and it's really, really fine. So if we're adding water to this, you know, it would get kind of bloom out. And maybe we'll go over to the water in a little bit and I can give you an example. So you might see bright red tufts floating in the water when you're hopping in the water to go for a swim. Same idea, really high branching. You know, there's a lot of places for animals to hide. And so if we were to gather this fresh, what you would see is there's tiny little shrimp-looking animals that are actually living within both the hypnea, the hookweed, and with this one, this one's like a red filamentous algae. Some of them don't have common names. We don't frequently give too many common names because, well, things happen. Like they call it gutweed and snotweed, which I think is not very nice to the seagrass or the seaweed. So the common names in this case are dependent a lot of times on the color. So other example, as I saw, there's another one called pom-pom algae. I saw some of that out here, so we might find that more in the water. Or here's some pom-pom. It's not very pom-pom-like when it's out of the water, but it's very fine, very filamentous. It's almost like hair in this case. Oh, there's a little snail guy living in there. Filamentous and normally attaches to something, so to a rock, and then once it gets really large, it gets kind of ripped up. So with the storm events, I mean, when you look at all of this grass that's on this beach, I mean, this is a pretty substantial chunk of seagrass that's here. So it's a natural process. The leaves shed, and then they grow new leaves. So as a monitoring person, that I'm going out into the bay and trying to track the cover of seagrass over time, I'm looking to see, so is it part of a natural fluctuation, or is this kind of alarming? Have we lost too much of the seagrass, and what causes that? So one of the monitoring stations here also involves the temperature. So I already talked about the soil is really important. Temperature is really important. If it gets too hot, then the seagrass actually will die. They'll shed their leaves prematurely. Given that it's the middle of June and I'm in a wetsuit and a bit chilled, I'm not thinking temperature is a reason. This probably is more related to some storm activity and that natural shedding that can happen. I would like for it to be a little bit warmer, but we're not quite there yet. There's another couple of cool examples. So we have animals as well. We'll talk about those. So these are two other things. Once again, these were not placed here. We didn't like seed the beach with macroalgae, seaweed. So this one's super cool. So this one is called rockweed. You'll see this along the marsh edges or anywhere there's a hard surface for it to attach. You've got the rockweed that forms. And so it's more of a brown one, right? And so they have these little air bladders, and you can, let's see if we can get one to pop. You know, like when you do bubble wrap, it's like, you know, it might be a little too old, a little hardened. So you can pop them when they're fresher. There you go.
Here.
My mom's addicted to bubble wrap. She would always pop all of it. And so this is another example. Got one to pop at least. So they use the little air bladder so that when it's attached to a rock, that the fronds like float upright. So like if this were attached to a rock, you would see it kind of waving in the water like this. I just took my family out kayaking on Saturday, and we saw a lot of this in the water, big stands of it, because there would be some rocks and then it would float upright. So hence the name rockweed. It has adaptation so that it doesn't dry out too much. This one is not so far gone. I bet you can even put it back in the water and it would continue to grow. It's another reason why seaweeds can do so well, is that they can take up nutrients anywhere, and then they can kind of shuttle the nutrients where it's necessary. So rockweed gives you another example. Seaweed, not a seagrass. Then this other example, this one's a fun one. I had a student that was always terrified about getting this in the seines and the transects we would do, because it has a really weird, if there was like a way for you to feel this, it's like squishy. And the common name for this one is dead man's fingers. I don't know who was going around squishing dead people's fingers to know that that's the common name they went with. But this one also likes to attach to rock surfaces, and so some type of hard attachment. Instead of a root system, they have a hold fast, because it holds fast to the bottom. And so it's green, you know, and that one maybe a little bit more confusing. It's kind of as wide as the seagrass, but the branching here is really unique. So if you're on the beach, that would be another important distinction to look for. Other than that, we do have animals. I'm not all about the plants, although my students would argue that I'm always about the plants. So even in the rack line, you could be looking for things like shellfish. So we've got some mussels here. And then even farther into the water, you can see, might be able to see some of the shells that are in the water. Some of them broken, especially with all the birds that are around here. They're probably somebody's tasty little snack. I don't know, you can see some of the tufts that are floating. More of the marsh mud and seagrass blades. So all of this eventually washes up to the shore. So as much as you like to collect shells, I would encourage you to limit your collection, because that all goes back into the ecosystem, which is really important. It forms the basis of the attachment for more macroalgae. Other animals like to use them for homes. Other animals we found, our large friend that we found over here, well, he's expired. He's no longer with us. I'm sure you've seen these guys on the beach. See if they turn over. He or she. Who knows what this is?
How's our sound with the wind? Can everybody hear us?
Survey says. Talking to myself this whole time.
We have 19 viewers.
Woohoo! Horseshoe crab smells amazing. Susan would agree. I've always thought these guys are pretty fascinating, just because of how prehistoric they look and how they've been preserved within the fossil record because of this, you know, it's really hard carapace. And so forms an important part of the community, not only with it being live, but then the eggs themselves are an important food for the red knots, for the bird migration. So you can find a lot of this stuff here on the beach that you might have be able to identify, but then do you understand the role in the actual ecosystem? With seagrasses in particular, obviously I'm a big fan of them, and my encouragement is, you know, what can you do if you're considered, you know, how can I protect seagrasses? The main idea is if you are in a boat, just avoid those shallow areas where the boats are, or where the seagrass is. Those crop scars, so when a boat runs through a seagrass meadow, it creates really big scars. Envision if you took a truck out on your front lawn after a rain event, right? If you spun the wheels up and it dug holes into the front lawn. You need to do something to fix it. It's not, it could naturally regrow, but it's going to take a while, and I have a feeling, you know, you wouldn't be a big fan in your household of twisted ruts in your front yard. So instead, what we do for restoration purposes, we'll come back in and we can get some of the seeds. You can take the seeds from the seagrass and actually sprinkle them into some of the holes that might be there. And then those seeds can take root and hopefully regrow. That's one method, or you can actually collect some of the actual plants themselves and plant a transplant, really, like take a whole plant and stick it into the soil. I don't know, maybe some of the pressure stuff. It's amazing, the seeds themselves are actually really small, so they don't take up a lot of space, and each one of the plants themselves produces a lot of seeds. Not seeing here. We have some other examples, so we have other invertebrates. So this is another type of crab. He has no legs and, well, no body. So we're talking a spider crab in this case. I can handle a spider crab in the water. A spider on land, not a fan. And then we've got some sponges here, some bright red sponge. These are kind of interesting too because when you pull them open, sometimes you've got little critters living in there. We've got in here, so this is a seagrass blade that's covered in a tunicate. So if you can, it's somewhat like almost clear and translucent. Tunicates are actually pretty close relative to a vertebrate. They have a pretty involved filtration system and feeding mechanism, and so it encases around a seagrass blade, which isn't all that great for the seagrass because obviously now you can't get any light for photosynthesis, but you've got other leaves to pick up the slack, so some covering of tunicates is completely natural.
We do have a question here from Valerie. She says, do you have to regrade or fill in the hole too, I guess, when you're planting the seeds?
Yeah, that's a good question. So it depends on the type of hole. So if a boat goes through and scars a bed versus if there's a big blowout. So if there's a blowout, it means that the boat was most likely grounded on the meadow and gunned the engine to try and get off. So you've got a big hole. Putting more soil back in to keep it up to level has been really effective in some of, especially the tropical locations, in helping to restore the bed. So phase one would be get it back up to grade. Phase two could be some plantings on top of it. Depending on how big, if it's a big blowout, if it's a big scar, more intervention would be necessary. And then the type of intervention would be important. So whether or not you plant, eelgrass is a slower growing species. So while that's in our area the king of pigs when we want seagrass, because it's slower growing, you might want to use an intermediary species if it's present in the environment to help first stabilize that new soil that you put in. So in our area, Woodsian grass is the other. We only have two. Coming from Florida, I had a lot more species. So with just these two of seagrass, there's been some thought that, okay, we put down this other species that grows fast, it's going to hold down the soil so that when the eelgrass comes through, it can actually root into the surface. You can see, what's crazy is that you can see on Google Earth images, there was a study done looking 5-6 years that the crop scars are still there. It takes that slow of a time, and it's one of these things that just feeds back into not having grass there, because if there's not grass holding it down, then that water is going to come through and really wash out anything that tries to grow.
Where are you, Dr. Z?
I'm in New Jersey. I'm on Barrel Island, so just across the bay is around Beach Haven area. I don't know if you can see in the distance the orange water tower there. So it's in the lower portion of Barnegat Bay. It's one of the common field sites. I take all my students here and do research here once a month doing monitoring for the seagrass.
Is it difficult getting the seeds from eelgrass, says Matthew?
It can be. It depends on the harvest method that you're using. So down in the Chesapeake Bay, they've done a really great job of kind of turning this into a machine of gathering the seed and trying to restock their seagrass beds. They've really done an amazing job with that. And so the key is that the seeds come out in May. And so knowing that timing when they're producing those seed packets and coming out in timing that can come out selective. You do it by hand. So I need an army of undergraduates, which unfortunately can't happen this summer. But that's part of the goal, is that you go out and harvest by hand without causing too much destruction to the, we call it a donor bed. And then the donor bed seeds are used to then convert, whether that be to grow them out, so kind of like a greenhouse. You take the seeds to shore, put it in tanks, and grow it until it's a nice size seedling, and then transplant the seedling. There are some methods where you actually then, like I said, you sprinkle the seeds onto the bare areas and see what happens.
We've got another question. Someone has seen the bright orange and red version of the dead man's fingers. Is that called redweed or something else?
Bright orange, and it looks like
It's like a version of the dead man's finger.
and it's washing up on the beach. I'm almost thinking that's so. I'm not sure of a bright red. There was, agar. There's one called agar's redweed. There's graceful redweed. So as things, that's the other thing too, is that the pigments that are in here, as they die, they become brighter. And so what you may be seeing is one called agar's redweed. I don't see any on
All right, so for our questions, what's the maximum depth below water that seagrass can grow?
It's a good question, and as a scientist, I can't answer it in a single value. It's really going to vary based on how much is in the water. So doing work down in Florida, we had sites that I could be 30 feet deep, 40 feet deep, and I would have seagrass growing there. That water's a lot clearer. So around here, some of my sites, we were 9, 10 foot deep, and there was some grass surprisingly growing just because you wouldn't typically see it. And there are some sites that are just a couple feet deep and it won't grow because there's too much in the water. And so a lot of times what's in the water, it's either going to be riverine input. So around here, since we're close to the inlet, there's a lot of soil that's getting kicked up, so mud and things that cloud the water. Then there's not enough light for the plants. Towards the northern end of the bay, what happens is you get blooms of algae, but we're talking micro, so teeny tiny algae, rather than the seaweed, which is the really big macro algae. So seaweed is macroalgae tendon and microalgae.
We also got a couple, it might be a sponge and redbeard sponge that came up with that red.
Yes, so we showed you the redbeard sponge, so if that's something that looks similar. Sponges, even the coat, like the dead man's fingers is squishy. There's not really a tried and true way. I think that's part of the reason why it can be hard to identify, is that it varies based on the life stage. So when it's reproductive, it can look a different color. When it's been dried on the beach for longer, it can look a different color.
Another question, other than trash and debris, is there anything dangerous or poisonous that can hurt someone who's inspecting these grasses on beaches?
I mean, broken shell would be a concern. As far as if you're talking more animal or wildlife, anything that would be in there. I mean, I've gotten pinched by a few crabs in my day, which is painful. But you can certainly, if you were hesitant to kind of just stick your hands in like I am, you can certainly use your shoe to kind of kick things aside. But things that are in that rack line, provided that it's all natural, aren't likely to hurt you. Certain times of year we do get, like Portuguese man-o-war. We've had a couple of those over the years, but I think that's a clear difference from what you would see in a rack line.
I think we answered all, we're caught up with questions.
Great. Well, I'm happy to have brought a little bit of my world, as much as I could, given our windy weather, to our Facebook Live Lab sessions. As I said, we've got next week, Tuesday, we'll have a panel of faculty. So Dr. Mark Sullivan, we have Dr. Anna Pfeiffer-Herbert, who you met if you had watched the oysters, and then Dr. Suzanne Moskowski, who did our marsh walk. So we're kind of capping out, starting with a marsh walk and kind of ending up with a marsh walk as well. So it's been a really pleasure to bring these things to you, and if you have any questions, by all means, hit up our Stockton Facebook page. You've got, I have an Instagram page, so Stockton_Merle, Marine Ecosystem Research Lab, MERL. You can get information there and ask questions, and send me photos of what you find on the beach, and I can certainly help you identify them to the best of my abilities.
We have some viewers watching from Cape Cod, and a few more questions.
Oh, okay.
Do shellfish benefit from seagrass or vice versa?
Yes, actually, so part of my research is looking at those interactive components. One of them is the positive benefit. If you have some seagrasses growing near shellfish, they're going to still help stabilize that soil, which means that there's not going to be smothering on, for instance, an oyster reef. There's also the benefit of just that decrease in that carbon dioxide, so they do take up CO2, which can be detrimental to any shelled creature because it starts to dissolve a bit. Some of the research that we've been looking into is when we're restoring habitats, does it make sense for us just to restore eelgrass or seagrass, or should we do oysters or plants? Should we do other types of habitats together? And so there are additive components, and it's beneficial in environments that make sense that you start to restore both of them, that they feed off of each other. There's other examples, just that water filtration that happens with our oysters, for instance, helps improve water clarity. So sometimes if there's oysters present, we can get some seagrass growing where it otherwise wouldn't, just because of all of that stuff that gets into the water.
Nice. Does seagrass live in tide pools?
It depends on the salinity and the temperature, so most often not, especially if we're talking like a rocky, around here we don't really have rocky intertidal environments. I take my students to see like riprap shorelines as a model of that. So in the Northeast, you definitely have some harder shorelines. So in those tide pools, you wouldn't really anticipate seeing it. If it's a larger area that gets flushing, you might. But the main reason in the tide pools for our seagrass species is that temperature is a really key determinant on how successful. So like I said, that rack line being as large as it is might be an indication that there was a big heat stress event and the leaves kind of were given up from the plant. So a tide pool is a kind of an extreme version of that. And so only if it's not maybe a proper tide pool and gets flushing might you see some of the seagrass. Chances are, if you're seeing any type of vegetation in a tide pool, you're looking at some seaweed there. All the way from Cape Cod though, welcome.
Looks like we're caught up with questions.
Great. So on that note, we'll sign off from here. We'll see if we can't get our boat back and determine our next phase of explorations as marine scientists. So thanks for stopping in. Enjoy the rest of your days.